Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm good morning. So in this video, we discuss tutorial questions. Let's start with question number 1. Okay, two positive charge magnetic for Q and Q are separated by distance R. Which of the following statement is true? Okay, so they are talking about force, and we know that the force created will be equal in terms of magnitude, but then in opposite direction. I think the answer will be C. For question number 2, two positive charge equal in magnitude are separated as shown in figure 1.2. Which of the question electric field strength is 0? So you have two positive charge. So positive charge obviously producing electric field going out from the charge, right? So you are talking about the one along the x-axis. So maybe you produce in that direction and equally in that direction. So you need to find a point where they will cancel each other. So I can cancel out 1 and 4 because at this position you have two electric field in the same direction. So it's either 2 or 3, so the answer would be 2 because it is at the midpoint. So at point 2 here, if I want to draw, I have E with the equal magnitude, opposite direction. Let's see if this is my Q1 and Q2, then this would be my Q1, E1 and E2. Question number 3, electric potential from a positive charge decrease as distance increases. So that one comes from the formula. V is equals to KQ over R. So V is inversely proportional to R. So R increase, V decrease. Question number 4, electric field due to a positive charge is represented by figure 1.3. Between which of the following 2 points does electric field do 0 work on moving charge? So they show several points. Some of those points are on the same equipotential line. So you want to find, as long as it's on the same equipotential line, just write it down, same equipotential line means V is equal. And since you know that work is equals to Q delta V, Q not delta V, if V is equal, therefore delta V is equals to 0, work equals to 0. So basically you want to find 2 points on the same equipotential lines. So the answer will be C and D, or D and C lah. So the answer will be C. So as long as you move along this equipotential line, work is equals to 0. Okay, show some. Okay, question 5, they give you several equipotential line. They want to find the work done. They want you to state something about the work done lah. So work is equals to Q not delta V. So if I want to find which one is the greatest, I have to find which delta V is the greatest. So if delta V increase, work increase. So delta V over here is equals to 20 because move from A to B, so final tolak initial lah. So delta V is equals to, this is for question 5, V final minus V initial. In this case it will be VB minus VA. So 40 minus 20 is 20. 60 minus 40 is 20 volt. And the last one, 80 minus 60, which is equals to 20 as well. So the answer will be the same for our diagram. Okay, so the next question is question number 7. They give you 4-point charges are placed at the corners of square of side 10 centimeter. So each side is 10 centimeter. Okay, and then each charge has equal magnitude of 10 microcoulomb. Okay, so this one is for Q1, Q2, Q3, and Q4. So the first question, they want to sketch electric force diagram on Q2. Okay, so you have 4 different force. So we start one by one. Sorry, you have 4 different charges. They want you to find force over here. So basically, other than this one, you have 3 other charges. So you expect to have 3 different forces on Q2. So let's say this is my Q2. Oops. Okay, so interaction between charge 1 and charge 2, this is equal charges, so they will produce repulsive force, and in this case it will be to the right. And then between charge 2 and 3, between these two opposite charges, attractive force, so it will be towards the Q3. And then between 2 and 4 is the opposite charges, attractive force, so from Q2 towards Q4. So the first one just now I forgot to label, so it will be F on 2 by 1, F on 2 by 4, F on 2 by 3. Okay, and then that one's for question A. For question B, they ask you to determine the magnitude and the direction of the resultant force exerted on charge Q2. So for question B, if you want to solve this one, you can use the formula of F equals to KQQ over R square. Okay, so let's say if you use F21, it will be Q2Q1, and then R would be the distance between 2 and 1. Okay, so the distance here is 10 centimeter. This one is 10 centimeter. The only unknowns would be here. This one, the distance R here. So maybe we can calculate that one first. So let's say I put this one as R to 3. So you can see that this one is triangle, right angle triangle. I can find the R to 3 using theorem Pythagoras now. So I just redraw the triangle over here. See, R23, this one is 10 centimeter, 10 centimeter, then 4, R23 is square root of 10 square plus 10 square, 100 plus 100 is square root of 200, which is equals to 14.14. And remember that this one is in centimeter, so might as well I change to meter, 0.141 meter. Okay, so like I told you before, the first thing is that after you draw, the second step is that you have to find the individual forces. So that means I want to find F13, sorry, F21, F23, F24. Start with F21 first. So the magnitude of the charge is equal, oops, 10 microcoulomb. The distance for this one is 0.10, the 10 cm, you change to meter. Don't forget the square. If you calculate this one, you should get F21 equals to 90 Newton. Okay, double check the calculation again. The next one will be F23. So Q2, Q3, to 3, then this one. To avoid any confusion, I just flip this one. Okay. This one will be the same lah. Sorry, F23 wouldn't be the same. F24 would be the same. Okay, you have to use R23 that we calculate just now, 0.141. So you should get 45.014. Okay, and then F24 you should get exactly the same like this one. So just copy that one. I got square. And then the answer will be 90 as well. Okay, so after you found these values, obviously you have to do vector addition and subtraction lah. And the best way to do vector is that you do it in a table. So I'm going to show you how to do it in the table in case you forgot. So 90, 45.04, 90. So you have three different forces, F21, F23, F24, and this would be your F net at 2 lah. Just put F2 here. F2. Okay, then you're going to do X component and Y component. So we do the, normally I'm going to do the easiest one first, which is F21 and F24. So if you guys still remember, this is the diagram, just copy it down. Okay, let's put it over there. So that one is the initial, this would be the final, later we draw. Okay, F21 to the right, so you only have values for X component. Okay, just now we calculate, that one is 90. And then F24, only Y component, that one is 90. Okay, this one is 0, this one is 0. And because F24 is downwards, I have to put negative over there. And then for F23, F21 to the right, so that one is positive. Okay. F23, if I resolve that one, so I have F23x to the left, F23y downwards. So F23 for X component will be to the left, so that one is negative 45.014. I forgot to calculate the angle. But this one would be 45 degree, because this one is square. We go back to the diagram. This is it's a square, so every side is the same. So it will be 45 degree over here. Okay, so that one is easy. So cos 45, this one would be negative because this is downward. I mean, cos and sine is the same in this case, so because 45, negative 31.83 Newton. So you have to do the addition, you have to sum it up lah, ikut row, sorry, ikut column, this column and then this column. So it will be 90 minus 31.83, here I got 58.17. Okay, I can put the unit over here if I want to. Negative 121.83. Okay, so you have x component positive, it means it is to the right. So I can redraw and then y downwards. So this would be your resultant vector, f2x and f2y. So f2 is actually in this direction. Okay, so if I want to calculate f2, that one is triangle, you can use Pythagoras. Okay, so f2 is equals to 58.17. Okay, this one should be negative, but just ignore it because it will be positive. Because you take the square. So here f2 is equals to 135. And the direction, I just copy this one. Okay, if you're talking about angle towards the x-axis here, so you can solve using tangent theta equals to f2y over f2x, always y over x. Again, you don't have to substitute the negative inside here. 121.83 divided by, okay, so you have to take up 10, and then over here it is actually that angle over there, so I can say it is a below positive x-axis.